Well, welcome everyone. I'm going to be doing a little bit of tabletop networking to connect a small network together of these Raspberry Pi computers I've got here. If the exercise as a whole is going a little bit beyond what the course teaches, so I want to say straight at the beginning, don't worry about any of the detail, it's not important. So it's just to give you an idea of some of the principles and to give an example of doing some of this stuff in the real world. And then we'll talk to Mark a little bit afterwards as well. What I'm going to do is connect together the Raspberry Pis, but I'm going to do it a little bit differently from the way that you would normally do it at home. I'm not going to use a router. Instead, I'm going to use a simple hub and do some wired networking first using cables. And then I'm going to go and be adventurous, and actually I'm going to turn one of these into a wireless access point and connect the others up to it using Wi-Fi. So again, there won't be a normal conventional router in the system. This will be a wireless access point. What I can't do, but I can do that at home, is go a step further and actually turn this into a router itself by connecting an Ethernet cable from it to the internet through my domestic router or something. I can't do it here at the OU because our security policies would stop me from connecting a Raspberry Pi into the campus network. So that's essentially what I'm going to do. Let's have a look to see what people have said about where they are. Just have a look, see where we are in the country. All fairly local, I think, by the looks of it. In the UK, nobody too far away at the moment. So great, thanks. It'll give you a chance to see how the interface works anyway, so I hope you can join in with the later ones. Okay, so actually let's go on straight for another question immediately to ask if anyone has any particular experience of using Raspberry Pis. So if you want to fill in the next widget, which asks about the Raspberry Pis, that would be great. While you're doing that, I will just mention what I've got on the desk in front of me. I've got a couple of Pi 3s. These are the larger ones. There's actually a Pi 4 now, which I haven't got with me, but it's similar size, just a bit more powerful than these ones. But that's a Pi 3, and this one over here is a Pi 0. So the Pi 3s and now the Pi 4 are about £35, a little bit more expensive if you want more memory. And the Pi 0 is only about a tenner, so they're quite cheap things. Let's have a look at the widget and see whether we've got some replies to whether there's a couple of people have heard of it. Somebody is a guru, a couple of people may be a guru. So that's good if I get stuck and things go wrong. But it looks like there's a couple of people who've heard of it and not had much experience. So I think I probably will say just a little bit more about it. So if we look at the Pi 3 as an example, I've got one of them here, which is connected up to my keyboard, mouse, and to a monitor on the side there. And that, if we have a look at that, that is running a Linux desktop. So this is a Linux desktop with a whole lot of programs installed. It comes with a lot of programming, some basic Office things, LibreOffice there, internet access, there's a browser and so on. So it's a standard desktop computer, reasonable performance, about what you get for a relatively cheap laptop, and it's £35, as long as you've got a monitor and keyboard and so on to go with it. So it's quite a good deal from that point of view, and some interesting software on it as well, preloaded. So that's one way of thinking about Raspberry Pi. It's a cheap desktop. The other way is to think about the hardware, and if you look at a Raspberry Pi, it's basically a small circuit board with a large chip on here, which is the system on a chip. There's some Wi-Fi and Bluetooth there, various other components. Memory on these ones is on the back. But then it's got and essentially that is what is in the inside of a mobile phone. So it's really the circuit board is roughly what you'd get inside a mobile phone. But instead of putting a touch screen on it and a radio cell, they've instead put standard desktop connectors, USB, Ethernet. This is an HDMI for video output, and audio output and so on. So it's put desktop connectors onto essentially the circuit board out of a mobile phone. It turns it into a decent desktop machine. The other thing that you might notice are the pins. So these set of pins here are GPIO pins. You can connect all sorts of things up to them. So that makes it a very attractive platform for hobbyists, hackers who want to play around with things. You can also buy pre-made little circuit boards that plug on. So this one here has got a series of environmental sensors, which just is on a carrier that plugs onto that set of I/O pins. And a little bit further over, I have another one, which is a camera on a pan and tilt mount. So that's a servo-operated pan tilt mount, which is sitting on top of a Raspberry Pi 3. And I hope we'll be able to use all of these at some point during the demo. So they're quite nice, adaptable little things. I mentioned that what I was going to do was try and turn one of these Raspberry Pis into a router. And I've got another widget there if you'd like to express your opinion about whether you think that's a sensible thing to do. I should say that what started me thinking about this was actually talking to a colleague who was working in Africa and doing some environmental work, which is why I got the environmental sensor there. But he was working in an area where there is very little infrastructure, so no broadband internet, in places very little power. There may be some cell phone if you're lucky. But he wanted to put out a small cluster of environmental sensors. And I was thinking, well, if you did it this way with environmental sensors connected to small Pis, and maybe with one working as a central hub that could collect the data from all of them, then that would collect the data, and actually their sites are then visited every month or so by somebody with a mobile phone. So once they're there with the mobile phone, you could sync the data to the mobile phone and then take the mobile phone back to the office, which is then connected into the internet, and you can pool all the data across the country. So it seems like a kind of a useful idea in that context. Let's have a look, see what people think about the idea in general, whether we've got, oh yeah, a couple of people think it's a good idea. And certainly for what I was talking about, that would be. Actually, doing it at home is also quite an interesting exercise because it is a desktop computer as well as a router. If you make it work like that, it means you could get a good view of what's going on inside, and it's a good way of debugging what's going on, help you to develop your skills. So that's a good reason. In some ways it's stupid because of course you probably have a router at home anyway that your ISP gave you. But I think quite interestingly, I suspect that inside many of those little boxes there is a single board computer rather like this. It probably won't be a Pi, but it'll be something rather similar. And so they're working at much the same sort of level of complexity as we have here. Okay, let's get on and do something then. I should not quite ready to start plugging in cables yet, because I should do a bit of planning. Anytime that you go to set up a network, it would be a good idea to plan what you're going to do. So let me get a bit of paper and sketch out what I'm going to do. So to plan a network means thinking about what devices you're going to connect together. And in my case, I've got a couple of Raspberry Pi 3s. I won't do that one because I've not actually got any power on that. So a couple of Pi 3s. So let me just draw those as Pi 3 and another one as a Pi 3. I've got a Pi 0 as well. Let's just do it like that. And I also have my laptop. So I've got a laptop sitting here as well. I'm going to use that laptop to monitor the network and test what's going on. So let me draw my laptop as well. So laptop here. And then I'm going to wire them together. Now, to wire things together with internet, in Ethernet, normally you wire things into a switch or a hub, and I have a little one here which I'm going to use just as a hub to connect the wires together. So it's an easy way of connecting all the wires together. So I have what I'm going to call the hub here, and I will connect my laptop to the hub. I will connect that Pi to the hub. I'll connect that Pi to the hub by cables. I can't connect the Pi 0 because that just needs wireless. So that will have to wait for a bit. So there we are. That's the beginning of the physical network that I'm doing. Good idea to name your devices. So all the devices on the network will need to have a name. It makes a lot of sense if you give them individual names so that you know which one's which. And a really good idea is to be actually a bit methodical about that. So for example, using the name of the device in there helps you understand which device it is if you're looking at it remotely. So I'll probably use Pi 3 in the name. Another thing is to know who it belongs to, so I'll use my own name in there as well. But I've got two Pi 3s here. How am I going to distinguish them? Well, one answer is I put coloured stickers on these. So I've got a yellow one here, which got a yellow sticker on and is in my yellow case as well. And this one's got a green sticker, and that one's got an orange sticker, and so on. So I can keep them separate that way. So I have John's Pi 3 yellow, and I have John's Pi 3 green. That's the next one. And that one's the Pi 0, so that would be John Pi 3 orange, that is. My laptop's actually got a name that's given by the OU, a bit complicated, so I won't bother with that, but that has a name as well, so I know what that one is. Right, I've got some names. Most importantly, though, is I need some IP addresses. I'm going to use just standard IP v4 networking. So I need a network address for this network. I could use anything I want because this is going to be a completely isolated network. But if I were to connect it up to the rest of the internet, then I'd have to make sure that I didn't accidentally use Google's address or something. That wouldn't be popular. So it makes sense to stick to one of the private IP ranges, and one that you might well have come across at home anyway is the range that starts 192.168, and then the next two things are up to you. You can decide what you want. I'm going to stick to a number I've used earlier, which is 42 for the network and 0 for the last bit. So this is the network address now. This part here will be fixed, and I will vary just the last bit for the individual hosts in the network. And then I can give them IP addresses. I'm going to use static IP addressing. So I'm going to be able to do these all manually, and I will use sort of large numbers for my static addresses. So I will make this one .250 for my first one, and then 251 for the next one, and so on if I had any more. Now the Pi 0, that's not going to be connected with Ethernet, and it's going to be Wi-Fi, and normally that gets a dynamic IP address through DHCP. So at this point, actually, I don't know what that's going to be, so I'll have to leave that one for the moment. My laptop as well, which I already have an address 240, I've put aside for that one. So my fixed static addressing I've done. Later on, I was planning to turn one of these Pis into a wireless access point. Now, the wireless access point also needs a static IP address because that needs a fixed place, and then that's the one that's going to be giving out DHCP addresses. So let's call that .10. Often in a domestic one, it will be .1 or .254 at the ends of the address range, but it doesn't have to be, so let's make it .10. So that becomes our wireless access point or router. And then I can set aside a range for my DHCP addresses. And so I'm going to set aside .20, to .40, I think, for DHCP addresses. Excuse me. So I think that's all the planning I need to do. I've got a physical network there. I've got a naming convention. I know what they're all going to be called. I've given IP addresses to the static ones. I've set aside DHCP address range, and I've got one static address reserved for my router. I think I'm good to go. So let me put that to one side now, and I'll refer to that and actually try and put that into action. So I have my hub sitting here. I have cables in it. They need plugging in. So I have my yellow Pi here, and I have a yellow cable, so that makes life easy. I can plug that one in. So that's the yellow one. I have a green cable and a green Raspberry Pi. So let me connect those two together. That's easy. I have an anonymous laptop and a grey cable, so that I can connect together. So get it the right way up. So physically, I've now, I hope, done all the connections, and I can see a few flashing lights on there. So I don't know whether you'll be able to see the lights, but there are some lights flashing, so that's a good sign. I need to check that I've got some addresses set. So let me have a look at my yellow Raspberry Pi, which I've got connected up to a monitor with my desktop and keyboard, my keyboard and mouse. So I can go and change that. I'm going to do that through the GUI first of all. So just to show you that, I'm going to change the Ethernet 0. I don't want to do that. I'm going to disable IPv6 because I'm just going to use IPv4. Now, what was my address going to be? It was going to be 192.168, and then 42, and then 250 was what I set aside for my yellow one. Now that's a /24. That's the bit mask I need. Oh, do it right. 24/24. Okay. That looks good to go. So I'm going to do that and close that. So hopefully that has set the right IP address for that. My laptop is already set up, I'm pretty sure. So I should be just about good to go. I'm almost ready to test it, but we could ask whether people could suggest what software I should use to test a connection. So another widget for you to have a go at. I'm going to just go back to my Raspberry Pi and look at the monitor again. I did the setting using the GUI, but everything to do with the Raspberry Pi and Linux generally will end up on configuration files. So I'm going to have a look at some of these configuration files. Details don't matter, but this is the sort of thing that you will see in the last block of the course. Just for interest, we'll have a look at a couple of them. So this is in a file called dhcpcd.conf, and that's quite typical of a Linux command file. Let's just go down to the end and have a look. There we are. This is the last thing that's been put in. Here we are. I've got it now. Is this. So these are the things that just been added by the GUI, and you can see the address has been put in there. 192.168.42.250 /24 is what I put in. And so that's ended up in the configuration file. No IPv6, I said, and I left the routers and domain stuff blank because we're not going to be using that for the moment. So that's all good. I can get out of there, and we're all hopefully good to go. Let's have a look to see what people have suggested for software that I should use. Ping and traceroute. Well, traceroute is the thing that you would need to trace a connection across routers. But here we have no routers, so actually that's not really helpful in this case. Much better to use something at a lower level like ping. So I think I would go with the ping suggestion. ping is probably the first thing that you do, any network, to check to see that you've got connectivity. Okay, let's have a look. I'm going to see if I can ping. I'm going to turn to my laptop and type in a ping command. Let me just check that I've got connected to the right thing. Let's just make sure I am connected to the right one. Yes, there we are. Just in case it had changed behind my back. Ping. The yellow one was 192.168.42.250. So fingers crossed. Let's see if that's working. Oh, it isn't either. Let's see what I've done. What have I not done? Let me just double check. I think I'm going to have to just bring the network interface down and restart it, just see if that works. ifconfig, oops, 0 down. Let's see if that clears it. Otherwise, I might have to do a reboot and bring it back up again. And check to see whether that has worked. Oops, typo. 192.168.42.250, and it is up. So that looks as though that should work. Am I on the right? Yeah, that should be okay. So let me just try the ping again on my laptop. Yes, that time it worked. Okay, so that worked. I've got some pings. I obviously needed to reset the network interface, and I hadn't done it. So there we are. I've been able to ping from my laptop to my yellow Pi. Let's see if I can reach the green one as well, which I did set up earlier, so I hope that hasn't changed. Excuse me. That was going to be 251. And yes, that is working. Great. Let's see if I can do something a bit more complicated. Let's see if I can log into one of these and control it remotely. We have another widget that you can use to answer what software would be good for checking in remotely to a computer. I will just have a cough in the meantime, excuse me. Losing my voice. And have we got anyone answering yet, or am I a bit too premature? Oh, we got some answers. Okay, let's have a quick look then and see how we go. Telnet and SSH are a couple of suggestions. They're both good suggestions. Telnet is like ping. It's a really low-level thing. You'll find it on every Linux and Unix system. So it's a thing to go to. However, it's not secure. So anytime you use it on something that's connected to the internet, it's a security risk. So SSH is a better solution in that case. Telnet will be fine here because I'm not connected to the internet, but I will try SSH. So I'm going to go to my laptop. I'm going to see if I can do an SSH to my green Pi over there. So the command is SSH, excuse me, 192.168.42 and then 251. Whoops, I forgot to put in the user. I'm logging in as Pi at that, SSH Pi at that, yep. And it's asking me for a password, which is looking hopeful. And there we are, I have logged in. So you can see that it's announced itself as John Pi 3 green, and my prompt has now changed to be the other Pi, and I can list some files there and see what's on that particular Raspberry Pi. Now actually that's got a program on it that I can run, which will make the camera move. So if I use that particular program, we should be able to see it moving if I'm lucky. So there we go. That's the camera panning around and not taking my picture actually at the moment, fortunately, but there we go. So you can see it working, and I've done that, controlled it from my laptop over there. So a successful bit of networking using cables, I hope. Standard IP addressing, fixed, very simple. Let's see if we can be a little bit more ambitious and move on to do the wireless access point. So to do that, I need to do a couple of things. Let's see, I need to, first of all, I need to disconnect all the wires to make sure there's no cheating going on. So that's cables out. So cables out, all disconnected. But I'm still using my keyboard and mouse to operate directly on the yellow one, so I can change its configuration. And so let's have a look at some of that configuration. So I need to give a static address to the wireless access point, which was the .10 address. And I'm going to do that using the command line this time. So let's, the file I had earlier, if I can find it again, that one, and I'm going to just see whether, I have it already there, so I won't change it. This is from testing it earlier. So I have the WLAN 0 is the wireless LAN. It's already set up with my address that I wanted, 192.168.42.10, which is good. Not using router or domain server or something. Just to mention this one odd looking one, this tells it not to go looking for another network. So it stops it hooking into an existing Wi-Fi network in the environment. So that says don't do that. Otherwise we could get quite confused. So that's actually good to go. So I don't need to change anything. So I'll just get out of that. That's good. The other things I needed to check on, which again, actually I've done a bit of Blue Peter and got them ready, are the DHCP stuff. Now, oddly, that was a DHCP configuration file, but actually need to set the DHCP configuration somewhere else, an oddity. So Nano again, this is a simple editor. And the one I want is dnsmask.conf. There we are. And this one has got the DHCP range defined in it. And so you can see that the range runs from 192.168.42.20 up to 40. So that's the range that I wanted. The next one is the network mask, which is here as in dotted quad form. So it's 255.255.255.0. And then this odd 24 at the end is 24 hours. That's how long the lease lasts, the DHCP lease. So it means if you get an IP address from this as a DHCP server, it'll be good for 24 hours. After that, you might need a new one. The rest of it's commented out, so we don't need to worry about that. And again, that's all good. So I'm just going to exit from that. And the final one that you would set up is the information about the wireless access point itself. And that is in another file, which is Nano again, etc. Sorry, mine's gone blank a minute. Host APD dot. It's the same thing again. Another configuration file, the host APD access point. And this has got information, again, it's things about details about how the Wi-Fi should work. We can ignore most of that. These are the sorts of things that you might want to change, but again, I've already set it up. So the name of the network, and I've called it Pi LAN. So this is the one that we need to look out for when we go searching for the wireless. And then the passphrase, which is the password, the wireless password that you type in when you first connect to a Wi-Fi network. The other ones at the bottom are to do with security and so on. So WPA is a particular type of security. So again, actually, that's all good to go. So I don't need to change anything. So it looks like everything's all ready. So I should, in that case, be able to do some wireless networking. Back to my laptop. I'm going to turn my Wi-Fi on, which was turned off. So enable Wi-Fi. And now it should be looking for networks. And you can see some networks that have come up. And there we are. One of them is called PyLAN. So that is looking very good. So let me choose that. And it's asking me for the wireless password, which it's not a secret because you all know what it is, TM129 demo. So I've done that without making any typos. And there we are. I've got a connection message, and it looks like we've connected. So I've made a mistake again. I was connected to the Pi3 green over SSH, and I pulled the wire out. So that's not very clever. I'll just close that terminal and open a new terminal. Don't want that. Let me have another terminal, a clean one. Right, I'm ready to ping. Okay, so I'm ready to ping. I have no wires here, so I need to ping using the correct address over Wi-Fi. So what is my correct address? The correct address for my yellow device is the one that I set up as the host access point. So that I know should be 192.168.42.10. I've got a bit of an issue now. What are the IP addresses on this green one, and actually also the orange one as well? If anyone has any suggestions, there is a widget you can try and fill out. Meanwhile, let me do the ping for that. So ping 192.168.42.10, I said, was the wireless access point. My fingers are crossed. And there we are. We got some ping returns coming in. So that is a wireless connection to the yellow Pi, which is my wireless access point. Now, I really want to be able to go beyond that to the other devices in the wireless network now. So my green device and the Pi 0 over here, the orange one. So for that, I need to know the IP addresses. And I do have a bit of software that will help me work that out, which is what I had running in the background. And I'm going to just do that, start it running. Whether people answered a question, let's have a look and see whether people have made some suggestions. Okay, good suggestion. It might be .20 because that's the first one in the range of addresses. So definitely the new devices that have been DHCP clients to my DHCP server should get the .20 to .40 range. This one is the server, and that's got the fixed address of .10. So it's likely to be in the .20, .40 range. And if I'd never done it before, and if everything had been turned off, then actually one of them's bound to be .20. But actually, I've done this before, so it's probably not as simple as that. So let me have a look to see what I've got. None of them have appeared on my port scanner, so so that is not looking good. There are other ways of finding out, and one of them is just to check every possible IP address in the range to see what replies, and hopefully that would have worked, but it's come up with some answers now. So if I look back at my laptop, I can see some addresses, and I can see that Pi3 green has actually got the address of .22, and Pi 0 orange has got the address of 39. Well, we've seen me accessing the camera, but actually let's have a look, see if I can access the environmental one, which is on the orange one. So let me go back to my other window and do an SSH to that. So that's SSH pi at 192.168.42. What did I say? 39. Or our password. There we are. It's John Pi 0 orange, which is actually that one there. And if I list the files, I've got some different ones in there, and I do have a program I can try and run. Actually, let me see if I can do that one. Python temperature one. Okay, I'm going to run this. This is displaying the temperature that's on this little environment sensor. And if I've got my fingers warm enough and I put my finger on the temperature bit, you should see that temperature going up. Not very much, actually. So usually I have to get Daniel to do it. He's got warmer fingers than me. No, that looks like it's actually going down rather than up. I don't think that's going to go enough to light the... Part of the trouble is it's sitting over the power thing, so it's getting heat from the Pi more than my fingers. I'm not sure I can make it go high enough. The lights are supposed to come on. Right, I'm going to stop that one and run the other one, which I've got there, which is, you can see the temperature sensor anyway coming in. This one shows some other things as well, so you can see the temperature in some funny format at the top. And there's light. You can see there's a number there, light 6,000 at the moment. Put my hand over the top of it and the light level should go down. Take my hand away and light level will go up again. Accelerometer, you can see one of them, two of the figures there, there are three figures, two of them should be close to 0 and one's about 1. And if I tip it on its side, one of the others should become 1. That's the second one's become close to 1. And if I turn it a different direction, yeah, there we are, the third one's become 1. So that's a little accelerometer, the sort of thing that you have in a smartphone that tells you which angle you're holding the thing at. And you can see that those figures changing. So there we are, some little bit of environmental sensing going on there. Okay, I think I've done enough. Just to recap, we started doing some basic IPv4 addressing using cabling, just directly between the devices on here. I went a bit further. I turned this into a wireless access point. I was able to make wireless connections from there to that, and then across the wireless network to these other devices, which are only connected by Wi-Fi. There are no other cables attached to them, just the power there. That's pretty good networking, I think, in half an hour. I could go further if I was at home by connecting an Ethernet cable in here, putting it into a router, connecting up to the rest of the internet. There are lots of detailed configuration here, which I've only shown you a little bit of, and some more software that needed to be installed rather than a Raspberry Pi off the shelf. But there are recipes out there on the internet if you wanted to do something like this. So the sort of detail that you don't need to remember, you can always look it up. But I hope some of the principles have been interesting behind it, and a little bit of the fault finding and so on. So thank you very much for listening. I think we should switch over and talk to Mark now to see about how you actually do some of this stuff in the real world with some real projects. So Mark, are you there?
I'm here, yeah. Thank you. Hello, everybody. Thank you for inviting me on, John. So I'm an academic in the Institute of Educational Technology, and we've been working on a project called Marzi, which means together. And we've been very interested to see how local communities might be able to set up and run their own networking devices to enable knowledge sharing and problem solving for local challenges. And a bit like John's mentioned about his colleague in Africa, we recognise there are situations where people want to share information for their own devices like smartphones or laptop, but there might not be network or cell phone access, or these might be too expensive. And we're really keen on the idea that local communities should be empowered to take control of their own network devices to learn that networks aren't something you just sign up to as consumers and you do as you're permitted to by your service providers, but something you can learn about, control, customize, and maintain yourselves. We wanted a low-powered, low-cost network web server in the middle, something that was battery-powered so it could work off the grid, away from the internet, and we chose the Raspberry Pi. It's got a large developer community and it's open source. Our project developed a toolkit linking together some custom and off-the-shelf open source tools through a web-based interface, and we call this Samazi Zone, and it's freely available, so you can go to the web link and download. So perhaps I could tell you about some of the projects that we've been working on.
Mark, one of the interesting ones I think is the one that's environmental stuff on the Thames. Is that Creekside Discovery Centre?
Yeah, that's right. So Creekside Discovery Centre is a great environmental centre in South London where people get to pull on waders, welly boots and walk in the mud and discover the wonderful biodiversity that's on their doorstep. It's very experience-based. You get in there, you learn about the wildlife. But the Discovery Centre was really interested in collecting more data about the changing environment. We worked with them to build an environmental monitoring system. And if we change the slides, we can have a look at that. Here we go. This is a Raspberry Pi Zero, and it's got sensors. So the big box on the left has the Raspberry Pi and a red Ethernet cable. So the intention was that we had a Pi Zero that was inside the Creekside Discovery Centre network, actually on a wall. And the intent was that it would collect data, and you can see the sensors on the right-hand side in the right-hand box. And would send this data periodically to cloud storage, something like Google Drive. The Pi Zero sits inside their network, and the Ethernet cable connects it out to the remote network. So if we could have the next slide. We had some challenges. This was in quite a harsh environment. You can see two colleagues setting it up, and it would be important for us to be able to check it remotely to make sure it's working okay. So John's talked you through using some of the remote management tools. So for us in the Open University, 50 miles away, we wanted to be able to log into the device over the network. So we had to set up a fixed IP and tunnel through the centre's network. And then we'd first ping the device to check that it's connected and it's still running. And then once we've pinged into it to connect to make sure it's running, we would then SSH and go into the Raspberry Pi Zero itself. And then we could analyze how the system's running, if there are any problems, check if all the sensors are working, for example, check if the device is filling up and we need to clear the storage. And so this enables us, using these kind of commands that John has just shown you, to be able to check the health of the system remotely. It's a very fixed location, and we had power to it, but there have also been situations where we've been working stuff in more remote field settings.
Yeah.
And,
I was going to ask, one of the ones involved solar power, didn't it?
That's right. Yeah, I mean, you talked about your situation in Africa, and perhaps we go on to the next slide. The Solar Roller, South East London Community Energy, they have solar panels. They take them out to music festivals and art festivals, and people can hire their solar panels to power their musical equipment or their lights. They were really interested to see if they could start conversations with people who are wandering by and wanted to find out more. So we worked with them to build a Raspberry Pi web server that would allow people to find out more. And here you can see it circled in red. Here's the Raspberry Pi. As people went past, they could log in. It had a fixed IP address, so people could connect to it, because of course it's not picking up an address from the internet. It's a long way from the internet. And we used WordPress, the very common and popular blogging tool, to allow it, people to log in and see news stories, events, what's happening, to even find out the readings of the solar power system, and leave messages in a guest book. So we had to set it up with a fixed IP, and set DHCP to allow passers-by to connect to it. And as you've said, John, I mean, this was an interesting case because we were indeed, improving the company's own philosophy, running it off solar power itself. And we find that a Raspberry Pi takes about 0.35 amps, so it's possible to run it off batteries and solar panels, and we've indeed used these in Brazil and in a project in Guyana and indigenous villages. So it is very much possible with these small low-powered devices to run independent of regular electricity supplies. And give people a local connection where they can be in the local area. We might call it hyperlocal networking.
Yeah, that hyperlocal is a really nice term, I think, isn't it? I remember your Platanos tree example particularly is a nice example.
Yes, so this was another example in Greece, and I think we've got a slide with a poster advertising it. So we were working in a rural community in Greece, a lot of the villages with older populations, and they were very keen in this village to share local knowledge that's not written down. So normally people would come to the village square underneath the Platanos tree, share stories, have a meal, and they're very keen that the younger generations would take on the stories and we could continue the stories over time. So there was this idea of using a Raspberry Pi to build a digital Platanos tree, a place where people could come together, share stories and capture conversations. So there's a local mountain dialect with local names for plants, and there's a local magazine. They wanted to scan and archive, digitize the pages so people could access these, and also to be able to take them around the different villages. So the fact it's battery powered was very important for us, and this sense of hyperlocal, that you would need to go into a space to share the stories, and it would add a digital layer onto the storytelling that was actually happening, but it would collect them and collate them for later and could be taken to other places. And I think we've got a slide of people using it. So again, we used WordPress as a blogging tool, and a document repository, Nextcloud, which is a bit like Dropbox or these other files storage tools. So this allowed the community to store images and scans of the magazine, and video and audio. And here we, as well as a fixed IP so people could access it and log in, we had to set a short DHCP lease time because if we had a large number of people accessing, we'd run out of IP addresses, but this would allow people to drop in briefly for 10, 15, 20 minutes and see what was happening. And it made us aware that we had to think about multilingual support and also thinking about how to make local administration nice and straightforward for people who might not be computer experts, but would nevertheless want to use these digitally enhanced tools to help collect their stories. It certainly it became widely understood and sort of loved as a sort of internet in the pocket, a small portable device. But we also had to sort of help people understand that it wasn't Google, it wasn't as powerful as the internet. So it was this local storage device for hyperlocal networking, and perhaps we were getting about 15 people a time can connect quite happily. So some practical examples of how the software tools that John's talked about, that you've talked about in your session, can be applied in the real world to help set up and maintain local systems for solving community knowledge sharing. Thanks.
Well, thanks very much, Mark. That was really great. So I think time means that we should ask if there are any questions. So Daniel, you've been checking on the chat to see if there are any questions coming in?
We haven't had any questions through the chat window yet, but anyone who has questions, I do encourage you to post them up now. But while we wait for that, we'll just go through a couple of mine, I suppose. So I've got a quick one for John, which I promised the students I'd ask, which is, you did all of your networking planning on paper, and I was wondering if you could talk briefly about what you see as the pros and cons of doing it on paper as compared to using a more technical system, like using a simulator, like the students use Packet Tracer in the block?
Well, for something that's sort of tabletop and so on, just a messing around, then I think actually paper's really good. Just a quick way of checking things out, and you can scribble over it. So I think I would probably always start with paper myself. If you're into a large network and maintaining a large network, then you're probably going to need something a bit more formal, something centrally administered and so on. In other words, something online as a register of your names and addresses and so on. And of course, there are tools that will discover things for you as well. Actually, I don't think I'd use a simulator. And the point of a simulator is actually to do the simulation. It's to try out stuff. So I don't think it's a useful documentation tool. It's a bit heavyweight for just drawing a picture. Excuse me.
That's great, thanks, John. And I hope that answer matched what those who had tuned in were thinking when I posed the question to them earlier. So my second question is, I suppose, more aimed at Mark, where John's given quite a nice demonstration of some of the debugging techniques you use when working in quite a closed environment. I mean, John's in a lab setting. I wonder if you could talk about some of the practical difficulties you've experienced of building and debugging networks in the wild, if you like, in these community settings.
Sure. Rats eating cables. We didn't expect that. It's not written up in TM129 about checking your cables for rats eating them. So that's maybe one real world thing that you don't get in the Cisco networking book. But we actually did have that problem. But that does bring you back to the things that John have been talking about. First of all, having a kind of a structured way of thinking your way through your network, understanding your network. So can you ping a device? Can you log into it? How far can you get across your network? These kind of practical and methodical approaches to checking how your network is running and where the problems might be. So we talked about the sensors dropped into the Deptford Creek near the River Thames. This was something where we would have to first of all see, could we get across the network to the Raspberry Pi Zero, and from the Raspberry Pi Zero, could we then get out to the sensors, and this would help us. First of all, pinging, then SSHing, and seeing the health of the system would enable us to understand where challenges or problems might be. Sort of looking across at these things, often, real world is it's more messy perhaps than a lab-based thing. But the way that John's shown of just practically, methodically checking through can help reveal where the challenges are. But sometimes in the community settings, it can be all sorts of things that might cause problems. I think we had one network where we helped build a community network, and the network stopped working at 7 o'clock in the evening, and it turned out somebody's car alarm was interfering with the network. So, I mean, again, it was just observation and methodical checking through can often help.
It makes me think there was a case in the news a couple of weeks ago, if anyone caught it, of a very old television set in rural Wales, which
yes,
had massive issues on people's broadband whenever it was turned on. So these things do turn up. We do have a question that builds on some of that from one of the students who's tuned in about unexpected issues either of you have experienced really with networks you've set up. I guess thinking more on the practical side than the technical side. I don't know if either of you have things to add there. John, I think, is poised.
No, I'm poised to say I think Mark's probably got a lot more experience, particularly in the more challenging areas. I mean, you've worked out in quite remote places, haven't you?
We've certainly tried Raspberry Pis South America and Guyana and indigenous villages. I'll talk about some of the Raspberry Pi things, John, but please, both of you, do pull me back into the kind of TM129 territory. you know, you can embellish them with real world challenges. But temperature was one thing. If your device isn't working, we first encountered that in Hackney. We thought we'd been very sensible putting things in weatherproof boxes, and then we had a great summer, and then realised they were in tin boxes, and by crikey, opening the boxes up, they were fairly cooking inside. So that, you know, these poor little Raspberry Pis were overheating, and we had the same thing in South America, where we discovered the place we were keeping them was in the shade, but they were under a tin roof, which again in tropical, equatorial South America were really sending it way above the 50 Celsius that they could cope with, and people using checking power. I mean, the one thing, I mean, the Raspberry Pis have got the little mobile phone connectors on them, which is great because it means you can use lots of cables, but it does mean that people are tempted just to pull the nearest charger off their nearby device. And I think John had mentioned this with the Pi Zero. At some point you'd had problems with the power dropping below the amount that it should have taken, and that can cause, so sometimes you can be scratching your head and wondering what on earth is causing something to fail, and sometimes it can be a hardware situation. But, you know, again, I don't know what you'd like to comment on this, John, but, you know, having a clear idea of what your network is allowing you to step through it, I found quite helpful in these cases to at least isolate where the problem might be.
I do remember one slightly old story now of a colleague whose job was to look after the network, and there was an intermittent fault, and he had a network map on the screen and would watch for this problem to happen, and as soon as it happened he'd jump up and go and try and find it. Cut a long story short, the cable was actually running in front of his desk and he had his feet on it, and there was a bad connection there, and so every time he got up it was fine, you know. It was actually his foot on the cable.
But, you know, I think checking the settings, I think is, and we talked about DHCP leases, and again, you know, we had a situation where the system seemed to stop letting people get on board, and there was a real panic about why nobody else could access it. And we found out that the default settings of the DHCP leases about how many people could log in and how long they could log in for, it was being held for 24 hours. And I think it was a Class C address, so do correct me, John, but that's 240-ish addresses that people could use. And this was a Raspberry Pi as a bit of a guest book and an information point in a cultural festival in somewhere quite busy. And so more than 240 people connected in the first hour, and then suddenly it stopped working. So going back and setting the lease time to be less than 24 hours, but just to be an hour, so people could come in for it, because they were only coming in for a few minutes just to find a little bit of information out. So again, learning, you know, sort of becoming aware of where some of these common files and configuration files are. This is really helpful, and you can be really scratching your head, and sometimes it can be just a simple fix.
That's great. Unfortunately, we are running out of time, so I think I'm going to wrap the session up there. Thank you both to John and Mark. I think it's been a really wonderful mix, really, of practical demo and then discussing how some of that works out in the wild. I hope those of you who tuned in enjoyed it as much as I did. As I think John said earlier in the session, the content we've covered goes way beyond what we actually assess in TM129, but hopefully the material gives you some context as to how the things you are learning in the module actually apply out in the real world. So we look forward to seeing you all on the next Labcast, which will be focusing on Block 2 on the robotic side of things. For those of you who are eagle-eyed, you might just see half of a picture near John of Baxter, our tame robot we have. We also wish you the best of luck with the rest of Block 1 and TMA01, which I know is coming up soon. And otherwise, we hope you really enjoy the rest of your evening. So it's good night from us.
Good night.
Good night.